on the exterior angles of polygons. ACT likes these. There's usually at least one of them on there for the geometry section. So there's a formula for those, but obviously I don't really like formulas you have to memorize because they don't stick in your brain very well. So the reason...
At this time, we will be having a hall clearing code.
Okay.
Teachers, please keep students in your classroom at this time. Hall clearing code.
Okay, so anyway, so the interior angles are like a triangle, you guys know, I think is 180. Do you guys know a quadrilateral? Does anyone know how many degrees is in there? Does anyone have a guess? Do you know? Yeah. Yeah, 360 is a quadrilateral. Pentagon, I don't know if you know, but it's 540, and then hexagon 720. I have them memorized because I like teach this class, so I like remember them because I've done it so many times. But this is like the formula for it. It's n minus 2 times 180. So the n is the number of like sides. So you're like, oh, I'll just remember it for the rest of my life. Probably not. Like, no offense to you, but like, what I do is I remember that for a triangle, I just remember triangle. So a triangle is 180, right? So if I were to do the formula, right, it would be the 3 and then the minus 2, because there's 3 sides, minus 2, and then times 180 for the formula. So it's like 3 minus 2 is 1, and then 1 times 180. But that's kind of pointless because you already know it's 180. Quadrilateral is, again, if you did the formula, there's 4 sides, and then you go minus 2 times 180. This is how I do it. Like, you start at a vertex and draw a line to every vertice and count the triangles. So like in a quadrilateral, do you see how you can make like 2 triangles? So that's why it's 360, because you can make 2 triangles in it. So 180 plus 180. And then same with pentagon. Like, start at a vertex, okay? So if you start at a vertex and then you draw like the lines to all the sides, or I'm sorry, to all the vertices, this one you make 3 triangles. You see that? 180, 180, 180. So you just do 180 times 3. Again, if you're the formula person, I don't recommend, because I don't know if you'd remember it after a couple of years. But like, there's 5 sides. 5 minus 2 is 180, you know. So, or 5 minus 2 is 3, and then times 180. But it's because that's how many triangles you can make in the shape. So I draw the shape, start at a vertex, and then draw the lines to all the vertices and count how many triangles I have. That's what I do. So like this is 180, 180, 180, 180. So it's 4 times 180. So that's how I get them all. So what's nice about these formulas, they're pretty like intuitive. Like you can kind of think about, you can usually just figure it out just by like doing this strategy. So anyway, that's the formula for the total, okay? Now, if they just want one interior angle, so this is like if you add them all up, okay? So like total degrees in the whole shape is like how many triangles it is. But say you just want one of them and it's like fancy, like it's a regular one, like a regular polygon. So regular polygon, that means all the angles and sides are the same. Like, you guys have done it with triangles, like the equilateral triangle, all the angles are 60, because you just do 180 divided by 60. Like the formula for this one, you figure out the total degrees. So this is like the total degrees in the whole shape. And then you just divide by like how many sides there are, or a number of angles. So it's like for a triangle, I do 180, and then if I wanted one angle, I divide by 3. But like for a pentagon, that has more like degrees in it. It's not just 180. So I'd have to figure out how many degrees is in the whole thing, and then divide by 5. So I'll probably just do the examples with interior, and then I'll go to the exterior ones later, okay? Okay, so I'm just gonna turn the page and do, because 1 through 4 are all the interior angle problems, so then we can just kind of focus on those. So 1 through 4 are all interior angle problems. And then we'll do the exterior ones later. So like, find the sum of the measures of the interior angles of the convex nonagon. So it's like, you kind of have to remember all the names for the shapes, but non kind of sounds like 9. So you could do the formula, which is fine. I don't know if you'll remember that by the time you take the ACT, but if you want, you can. But like, it's a nonagon, so there's 9 of them, and then you multiply by 180. Like, that's the formula for it. So 7 times 180 is going to be 1,260 degrees. That one I don't have memorized because nonagon's not as common. But like, what I would do is like, because I forget the formula or whatever, but I'll go like 1, 2, 3, 4, 5, 6, 7, 8, 9. Draw 9 dots in a circle. That's how you can make a nonagon pretty fast. And then I do like the triangle thing. So I go like, start at a vertex, pick your favorite one. I don't know, I just did that one. So there's 1, 2, 3, 4, 5, 6, 7. Oh wow, that's 9 minus 2. Do you know what I mean? So like, this is 7 180s. That's how I remember it. So, because a lot of you are taking your ACT next year or the following. So you have to remember it somehow. So either way, that's what you do. If you have to do like algebra stuff, it's basically the first thing you do is you find the total degrees. Like degrees, so that you can either do the formula, or for me, I'm like, 3 triangles, 3 times 180. Right? So like, again, it's kind of like, I don't know which is easier for you, or if you do the formula, there's 5 sides minus 2. It's always minus 2 times 180, which is like 3 times 180. So 3 triangles, or do the n minus 2 thing times 180. But this is 720. No, 540. What am I doing? Pentagon, 540 degrees. So if it was a triangle, 180, quadrilateral, 360, pentagons, 540, yada yada. So then the second thing is you're going to add all the algebra stuff up to equal to the 540. So you're going to sum the angles to whatever you got. 540. So like, it's super long and annoying, but it's fine, whatever. So you're just going to go like 2x plus 142 plus 2x plus 3x plus 14 plus 3x plus 14, and that was all of them, I think, equals 540. And then you just like algebra to get it. So when they do like an octagon, then it's like really horrible because your equation's like super long. But it's at least just make sure you're adding everything right, you know. So is that 6 and 4? So that'd be 10x plus 28 plus 142. What is that? 180? 70. Dang it. Close. 540. And then subtract. So you get 10x. 70. So you get 37. So that's how you do those type. So find the total, add them all up to that. Okay. The other type of problem, this is just like a little bit more of an application. It says the poles for a tent form the vertices of a regular hexagon. When the poles are properly positioned, what is the measure of the angle formed at the corner of the tent? So like, you just want one of these. Like, that's like what you need to find, right? Like just one angle. So if you need to find like the total angles, like that's what you would do in like the step 1, you know, the total degrees, but you just want one. But because it says regular, that means all those angles are the same. So like all of these are equal. to each other, right? So the deal with this is figure out the total amount, okay? So total degrees, it's going to be a lot. And then just divide by how many angles there are, right? So you're going to divide by 6. So like that's like theoretically that's this formula, this n minus 2 times 180 over n. But it's basically you're finding the total. So to find one interior angle, you're going to do either the formula or like the thinking about it, like do the triangle thing. So this is the total, and then you just divide by like the number of angles. So this would be the number of angles, right, in the shape. So, okay, so then you're going to do, I mean, if I do the formula, again, it's a hexagon, so that's 6 minus 2 over 180, or you could do like the triangle thing, like 1, 2, 3, 4. So there's 4 180s. So 4 times 180, you get your number, and then you're going to divide because there's 6 angles in the shape. So you're going to divide by 6. And then you just simplify it. So you would get, so this would be what, 720, and then divide by 6, basically. So that's 120 degrees. So each angle, which makes sense, because if you think of like a hexagon, like they're obtuse, you know. Like I would freak out if I got like 20 degrees, you know. So that's like tiny. So, is there any questions so far? Okay, so so we did total algebra thing with total, one angle, and then this is the hardest one, I think, is they give you the interior angle and you have to find the number of sides. So that one, you kind of have to use the formula a little bit, like, which is kind of rough, but like here we had to find the 120, you know. But now it's basically what I'm going to do is I'm going to put the 135 like in here, basically. So like I'm going to take the 135 equals, and then you need to figure out the number of sides, but that's the n. So you're going to do n minus 2 times 180 all over n. So it's the same thing as the one above, but now you're putting the number in a different spot, basically. And now you're going to like algebraically solve it. So as far as like solving it, I would multiply both sides by n to get rid of the division, because I don't like them all. I don't like so I don't know how you want to think about that, but I'm just going to multiply both sides by n because I don't want the fraction in there. So if I do that, I get 135n equals n minus 2 times 180. And then people get weird with this now, but honestly, if you want, and maybe you might want to just do this. Oops, 180 died. Okay. If you want to put the 180 in front, you can. Maybe that makes you feel better. But you're just going to distribute the 180 and solve it. So, like, when the 180 is, like, second, people, like, freak out about it. But, like, you can just put it in the front. It's fine. So, you would get, like, here, you have 135n equals 180n minus 360. And then you just solve it normal. And then you might freak out because it's, like, I would subtract the 180 and then I get like negative numbers. So you're like, what is going on? So I would get like negative 45n, but it's equal to a negative 360. So the negatives ends up canceling. So it's fine. Like it'll work out. So you get n equals 8. Or you could say like octagon. But it just said number of sides. So that one's the hardest, I think. So again, I set it up with the formula. I don't like fractions, so I cleared it. So I multiply both sides by n to get rid of it. And then distributed the 180. You don't need to show this step. Like, you could just go straight into the distributing and then solve it. Any questions? Okay. So now we're gonna go back to the front and do exterior stuff. So why don't you guys work with your partner, maybe split it up or something. Find, add them all up. So like add up all the angles. And then I'll give you the answers in a sec. So add up all the angles. Ready, go. Did you add them all? Was anyone amazed? Oh my gosh. It is 360. Oh my gosh, all the time. Well, think about the exterior angles get smaller as you get the bigger shape. You know what I mean? Like triangle, these are pretty big. And then you look at pentagon, the angles get smaller because there's like more angles to do, you know? So it makes sense that they do add. Another way, if you still don't believe me, like it works for all of them. Okay, this is gonna be not as pretty, but we're just gonna try it. If I were to take them all, like the 120, and then here's 140, right? And then this would be 100. Do you see how it makes like a little circle? Right? If you were to like take them and like match up all their vertices, it makes a circle. So they do add up to 360. That's where the proof comes from anyway. But that's like the deal with exteriors. So interior changes because if you think about the shape, the more sides, the bigger the angles get. But for this one, the exterior angles always add up to the same because the more angles, the smaller they get. So they end up balancing each other out. So if we go to these guys, there's two types. Sometimes they just ask what they add up to, and that's easy because then you could just say 360. But like this one, the algebra one, this is the one where you're going to add them all up and set it equal to 360 because they always add up to 360. So again, super long and annoying kind of, but it's fine. So you're going to take 3x plus 10 plus 2x minus 5 plus 5x plus 2x plus 6x minus 5 equals y 360 because it always is. And then you just are algebraing up forever to do it. But all the numbers ended up canceling out. So you add them all up, you get 18. Save you the trouble. You guys know how to add. So then you get 20, right? Yeah, 20. So there you go. That's all you do. So super long and annoying, but that's what it is. And then the last one is find the measure of each exterior angle of a regular nonagon. So if you want each one, the key is each. So honestly, what people mess up, like these are all your exterior angle ones, by the way. Where it says each exterior angle, they want one, right? And it says regular. So that means the nonagon's like perfect. So what you're going to do is you could take 360, because that's what they're all going to add up to, and then think of how many exterior angles there are going to be. So it's like if it's a nonagon, aren't there going to be 9 exterior angles, right? So you're going to take, this is the total, and then you're going to divide by the number of sides. So nonagon, so this would be 9. Number of sides, and that's all you do. So this, what would that be, 40? So 40 degrees. Another way you could do it, say you had to find the interior angle. Say, I don't want to draw a nonagon because that takes too long. Maybe I'll do, okay, this is supposed to be regular, just go with it. Okay, keep in mind an exterior angle and the interior angle make a linear pair. So you can cheat a little if you need to. Like, so, like 360 divided by 5, what is that, 72? So if you found the exterior angle, you could find the interior angle pretty fast by doing a 180. So there's little tricks, a lot of it's pretty intuitive, but the homework's on My Math Lab.